All right, so this is lesson number 34, Hyperbolas Part 2. Good morning, everyone that we have here. It's going to be a shorter lesson. While I do attendance, I'm going to have you read these things, random things to think about. So read these. Don't necessarily require an answer. I spelled random wrong. R-A-N-O. So there should be no N at the end, sorry. But random things to think about. Read these and just think about them. Okay, awesome. We'll go ahead and get started then. This is, like I said, Hyperbolas Part 2. So you should have, if you weren't with us last class, you should have watched the video, tried the practice. It's going to be a continuation of that. If you didn't do that, you'd be a little bit confused. But this is Part 2. Sorry, Zane's crying in the back. So we moved a couple things on the calendar. If you remember, we moved this to yesterday. It was the last lesson. We're moving this here. We're not having a in-class lesson tomorrow. My idea was to mix ellipses and hyperbolas, but just to make sure you know when to use what. But I just put that in the practice that both ellipses and hyperbolas together. So get a little bit of a break. No lesson tomorrow. So it's a 2-lesson week. Friday Zoom office hours. If you have any questions on anything, that's always at 10. All right. So we're going to get started. We will learn math, build character, never give up, and ask why. All right, let's jump into it. So all we're talking about today in this lesson, this is just a small addition. Can y'all hear me fine?
Yeah.
Okay, a small addition, and that is the asymptote. So last class we talked about that all hyperbolas have 2 diagonal asymptotes. And so we're just talking about that equation of the asymptote and how you can kind of use the asymptote to help you with the equation. So if you look at the formula sheet here at the top, let me make this big. We have our 2 equations here for hyperbolas. Give me 1 second, okay? Hold on. All right, sorry, y'all. I'm back. So we have 2 equations of a hyperbola. We have the one on the left here. I'm at the top of your screen there. And that one is the equation for a horizontal hyperbola. And we know that because the A is under the X, right? And then we have this one on the right, which is the equation of a vertical hyperbola, because the A is under the Y, right? And that makes it vertical. So we talked about that last class. So we have here the equation of the asymptotes, okay, which is what we're talking about today. That should remind you of something. The way that's kind of set up should remind you of a formula that you learned about in Algebra 1. I want to give you a minute to think about that. The way that this is set up, that should remind you of an equation that you learned about in Algebra 1. What is that equation that this is set up similar to? And anybody can unmute themselves and share, or you can write it in the chat. What is this equation, these equations similar to? It's in a particular form. Point slope form. Maybe it's been a while since we did that. That's going to be the way in which you primarily write the equations of lines in calculus, by the way. You don't really use slope intercept form anymore. Okay, so just to refresh your memory, point slope, you're going to write it in that form when you have a point and you have a slope. You use slope intercept when you have the slope, which is the m, and you have the b, which is the y-intercept, right? Point slope form is when you have a point and you have the slope. And it's in the form y minus y1 equals m times x minus x1. the point being x1, y1. So that would be any point that is along the line is x1, y1. Your m being your slope. That is the form of a line. Hopefully that's coming back to us. So both of these are in that form. Y minus, in this case, your y1, you're using the center because you know that point. Plus or minus, we'll talk about as plus or minus. This is the slope. And then x minus x1, which we're using as the x of the center, okay? These are the equations of the asymptotes. Because if you think about it, let's look at the first one here. If we're looking at this asymptote here, just this one, your asymptote is always going to pass through the center, okay? Because the asymptote is always going to pass through the center, when you're writing the equation of the asymptote, you can use the center as your h and your k, or as your x1 and your y1, as the point that you are using. Is the easiest point to use because you know that you have it. So that is why in the equation for asymptote, for x1 here, it's h, and for y1 here, it's k. So you use the center there, okay? Then for the slope, it differs whether it is a horizontal hyperbola or a vertical hyperbola. The reason for that is because this one over here is horizontal, okay? And we see for the horizontal, this lines up. For the horizontal, the slope is b divided by a, because slope is rise over run, right? And so if we're going from this point on this line to the next point up here on this line, and you're doing rise over run to get there, your rise would be b, because you're going up b, right? And your run over here would be, that would be a, because this distance right here of a is this distance. So b over a is your slope, and that's why it says b over a for the horizontal hyperbola. It has a plus or a minus because you have two asymptotes, right? You can do rise over run b over a like that, and that will give you this asymptote. Or you could go from this point to this point to give you this asymptote, and that would be going down negative b over a, right? And so that's the two. That's why you have the plus or minus. So that's for the horizontal hyperbola. It's going to be b over a because that's your rise over run. For the vertical hyperbola, let's say you're finding that slant asymptote there. Now when you do rise over run, since this is the next point over here on this, you will be rising. That would be your a now. And your run would be b. So it would be a over b. And similarly, negative a over b for the other one. So that's why for the vertical it says a over b. Okay? Any questions on that? If you're good, you can put a thumbs up. If you got questions, some pause. Okay. I don't know if y'all can hear insane dancing in the background. Just to make sure when you don't have, let me add a slide here. Oh, I delete this. So just to make sure you would be good with doing that when you don't have that notes with you. Let's say you forgot, you don't have your notes, or you want to make sure that you know whether the slope of the asymptote is b over a or a over b. You can just do a rough sketch. So I would draw a vertical hyperbola. I would just do this. That's a vertical hyperbola. and I would draw my asymptote, just one of them, passing through the center. And then just to figure out whether my slope of the asymptote is b over a or a over b, I would just do this right here. And I would say, okay, from here to here, is that a or b from the center to the vertex? And based on what we talked about last class, that's the a. So that's a, and then this is b. So you know the slope of the vertical is a over b. And then for horizontal, I would do that. I would draw an asymptote. And I would say, okay, rise over run, I'm going up, that's b, and over, that's a, because that corresponds with this. And so then you know the horizontal is b over a. So plus or minus for both of them. So you can just sketch a graph roughly like that to tell if it's b over a or a over b. Okay? So in this case, let's say you're trying to find the slope of this, and you have a graph given to you. This is a horizontal. So when you do rise over run, up 2 over 1, 2, 3, 4, 5, 6. So your slope there is rise over run is 2 over 6, which simplifies to 1 over 3. So the slope of that asymptote is 1 over 3. And if you wanted to write it in the equation, since it's horizontal, we're using this one. Our center is 2, 1. So it'll be y minus, we're using this point, so y minus 1 equals, and your slope, but it's plus or minus that. So plus or minus 1/3 times x minus your h, which is the x value of the center, 2. So this equation is going to be the equation of this and this asymptote. And you could leave it in point slope form. You'd have to convert it to slope intercept. It didn't ask for the equation, it just asked for the slope, but just to make sure you know how to do the equation. So y'all go ahead and y'all try the second one there, the one that says slope of the vertical. Find the slope and also write the equation, okay? I'll give you a few minutes to do that and then I'll ask.
We can find the center, which is at 2, 2.
Okay, good. We can find the center, 2, 2. So Tammy, give us another one. What else can we find? We got, from the vertices, we got.
A is 4.
Okay, good. We got the A. That's the distance from the center to the vertex. That's 4. Jair, what else can we find?
We could try to find the B.
Just from the information we have, though, like from the vertices, that is, not the slope. Just from
Oh,
we could find the B in a minute, but just from the vertices is one more thing we could find out. Still there, Jared? Can y'all help him out? What else could we find? We got the center, we got the A. There's one more thing we can determine from the vertices.
That is horizontal.
Yeah, that is horizontal because those are our vertices. We know it's going to go something like this. So we know it's horizontal. And that's important because it helps us to know which equation we're going to use. Okay. All right, then we can now look at the asymptote, okay? Because we know it's horizontal, when we're using the asymptote and we're thinking about rise over run, is it going to be B over A or A over B there? If it's horizontal like this, like when we do rise over run, is it B over A or A over B?
B over A.
B over A. So 3 over 2 is equal to B over A. Now it's important that we set up a proportion here because sometimes the slope will be simplified as we saw in the last example. because we can see that our a is 4, but this is a simplified version of something divided by 4, right? So I like to set it up and say this equals, I'm gonna put the 4 at the bottom and our b that is unknown, and I'm just gonna see the proportion. So to go from here to here was multiplied by 2. So then this would be multiplied by 2. So your b is 6. So 6 over 4 was simplified to give you that slope of 3 over 2. But you want to write the non-simplified version because that's the actual b that's going to be visible in the graph of the hyperbola. So your b is going to be 6 there. And so really that's we don't have to write the equation of the asymptote. We just need the equation of the hyperbola, but that's all the information we need because we know that it's horizontal. We know we're using this equation. We have the center. It's going to be x minus 2 squared over a squared, which is 4 squared 16. My computer froze. I realized that. It's not showing y'all what I'm writing, is it? At least on my end, it's not showing that. I have it written on my iPad, but I'm not showing that it's. Can y'all see what I wrote?
Yes.
Okay. And then minus y minus k, which is 2 squared over b squared. So the b is 6 squared 36, and that equals 1. So that's the equation of our hyperbola, and we can check our work if we wanted to by graphing that and seeing if it matched up with the visual. So that's it. Any questions? All right, I'm gonna have y'all try one on your own, and that'll be the last one we do together. Just make sure you feel comfortable. So y'all go ahead and try this one. Yeah, I'll give you some time. A couple of messages saying that some of us were a little bit stuck. So let me work through it. However far you got, you can kind of check what you got so far, okay? So we have a center at 1, -3. So that's right there. We have a vertex at 1, 1. That's right here. So we have a center and a vertex, and that will help us to find 3 things. We know the center is 1, -3. We know the A is the distance from the center to the vertex. So we know our A is 1, 2, 3, 4. We know where our other vertex is, 1, 2, 3, 4 down here. And we know that it is vertical because we have the 2 vertexes. So it's something like that. Okay. So really the only other thing we're missing is the B. And because we have the equation of an asymptote, now notice this equation is slightly different than this, right? This one is in slope-intercept form, which is y equals mx plus b. So that one has already been simplified. But we can just pull the slope from there. So we can pull the slope, the m, which is -2/3. So the slope of the asymptote is -2/3. The negative just means that they took this asymptote, right? You don't need to necessarily worry about the negative when setting up the proportion. We have and this is going to be, since it's vertical, and if we're thinking rise over run and we're doing that one, it's going down as our rise, negative, and that's A, and to the right, that's B. So it's -A/B. And the A we have from here is 4. So we set up our proportion 4 over B, which is, that's what we need to find, right? So if we look at the proportion, I'm ignoring the negative. I can put this negative here if we want, but just what are we multiplying by is really what we're looking for, excluding the negative, because it can be positive or negative depending on which asymptote we're talking about. So we're multiplying by 2 there, -2 times 2. And so if you multiply this by 2, that would be 6. So your B is 6. That's the proportion. 4 over 6 was simplified to give you 2/3. And so our B is 6. And so then we can write the equation using the vertical. So it'd be y plus 3 squared over a squared, which would be 16, minus x minus h, which would be 1 squared, over b squared, which would be 36, equals 1. Okay. Did that clarify for us? For those of us who are stuck a little bit there, any questions on that? Okay. So that is ellipses and hyperboles. Hyperbolas. I say hyperboles. We did ellipses last week. We talked about conic sections. This is kind of the end of our unit of conic sections. Next week we'll move on to a new unit. Remember, the rest of this kind of sequencing calendar is mainly BC topics, and they're more separated. So hyperbolas, we just did that. This was today. This was supposed to be Tuesday, but we're not doing that. Or that was supposed to be Thursday. I'm sorry, we're not doing that Thursday. So there's a practice that's posted on Google Classroom there. So for this week, you should have 2 practices that you're responsible to do: hyperbola part 1 practice and hyperbola part 2 practice, both of which are posted on Google Classroom. And those are all due Friday at 4:20. So it's a little bit of a lighter week this week. Next week, we'll start a new unit. I believe it's parametrics. And then after that, polar. So we have 2 more weeks of content. Then the last 2 weeks during AP testing, we're going to just do review, because I want you to be able to focus on your AP testing.